Hello everyone and welcome to iLAN Technologies presentation, and today we'll be looking at hardware acceleration in Draitec routers. My name's Darren and I'm the Queensland sales rep at Draitec Australia and New Zealand. I'll start by looking at what hardware acceleration is, then I'll go into how it works, its limitations, and I'll also go through the configuration options available as well as some troubleshooting tips. If you have any questions during the video, please comment in the chat box on the right of the screen and stick around at the end for a 5-minute Q&A session. Don't forget you can pause the video or skip back any time if you'd like a longer look at anything or to hear it again. If you're watching this after the premiere, please comment below or send an email to sales@draitec.com.au. So let's start by looking at what hardware acceleration is. I have a definition here from Wikipedia that says hardware acceleration is the use of computer hardware designed to perform specific functions more efficiently when compared to software running on a general purpose central processing unit. As shown in the diagram, Draitec routers have a dedicated hardware component labelled as accelerator, which performs tasks which are usually handled by the CPU. This means the CPU will have less load and perform better. We sometimes see the term software acceleration. How is that different to hardware acceleration? Well, software acceleration is the technique of optimizing system functions in software and delegating performance-critical functions to specialized external hardware. Hardware acceleration uses dedicated hardware running fixed algorithms to greatly improve performance. Later model Draitec routers such as the VIGA 2865 and VIGA 2866 series have a dedicated hardware accelerator component that processes data directly from memory and sends the result to the CPU. This greatly reduces the workload of the CPU, which results in an increased NAT throughput from 500 megabits per second up to 900 megabits per second. Draitec routers use hardware acceleration to provide increased WAN throughput through NAT acceleration. Hardware-based QoS was introduced in firmware version 4.4.0 in later model routers to greatly improve quality of service performance. This is an improvement over software-based QoS processing, which placed a load on the CPU, which under heavy traffic conditions may have not been able to efficiently process all of the data. Hardware acceleration in later model Draitec routers greatly improves IPsec VPN performance as well. The limitation here is that IPsec NAT-T encapsulated packets cannot be accelerated. Other types of traffic that can be accelerated are any TCP packet. After the three-way handshake, the fourth packet of the TCP session will go into the PPA. That's except for TCP port 21. VIGA routers support FTP ALG by default, so they won't let TCP port 21 packets go into PPA. PPA is an abbreviation for Protocol of Processing Accelerator API. Also, UDP packets are accelerated. Here the UDP session is created after 3 packets except for port 53. VIGA routers support DNS-related functions, for example, acting as a DNS server for LAN clients, DNS forwarding, DNS filter service, and so on. We don't let DNS packets go into the PPA so that the DNS packets can be checked by the router and the DNS-related functions can work correctly. Some types of traffic that cannot be accelerated are listed here. That includes sessions to local services such as HTTPS, Telnet, DNS, and VPN. Non-TCP or UDP packets like GRE and ICMP packets. Traffic from a non-directly connected LAN, and traffic from a host IP with an unknown ARP address. Now let's look at how hardware acceleration works. Draitec routers have a dedicated hardware component which is labelled as accelerator in this diagram. It basically performs tasks which are usually handled by the CPU, which means the CPU will have less load and will perform better. This flowchart shows how data packets are processed in the router when hardware acceleration is used. You can pause the video here if you need more time to study the diagram. Okay, let's look at a short animation. Usually the CPU handles all traffic and sessions through the router. For the VIGA 2927 router, the total WAN throughput is 800 megabits per second, regardless of whether a single WAN or both WAN connections are used. This is the limit of the CPU performance. The hardware accelerator can process up to 8080 connections, delivering up to 940 megabits per second throughput on a single WAN, which is a 1.2 times improvement in speed. With dual WAN connections, the router can achieve up to 1.8 gigabits per second combined throughput with hardware acceleration enabled. This gives us a 2.3 times improvement in WAN throughput. The 2865 series routers can achieve 940 megabits per second throughput through the Ethernet WAN port. When combined with the DSL port, we get up to 1.6 times improvement in WAN throughput when compared to CPU-only mode. Another improvement in the latest firmware is hardware quality of service. By default, VoIP traffic always has the highest priority when processing data packets. With a few clicks, your business-critical applications will be prioritized. Next, we have hardware IPsec. In the latest Strateq router models, up to 16 IPsec VPN tunnels can be accelerated. In the VIGA 2927 and 2865 routers, IPsec performance is 290 megabits per second when software mode is used, but with hardware acceleration enabled, IPsec performance jumps to 800 megabits per second, which is 2.8 times faster. The first 16 IPsec tunnels are handled by the hardware accelerator, with the remainder being handled by the CPU. When a VPN tunnel is disconnected and removed from the hardware accelerator, the next VPN tunnel being handled by the CPU is automatically moved to the hardware accelerator. There are a number of limitations we should mention when using hardware acceleration, especially in older router models. In older model routers such as the VIGA 2862, 2926 and 2952 series, when hardware acceleration is enabled, the traffic graph is bypassed, so you will not see accurate recording of WAN bandwidth usage. Another limitation in these routers is that WAN budget will not accurately record data traffic through the WAN interface being monitored. This can cause problems if you have a limited data quota for an LTE connection and you don't want to incur additional costs for the extra data used. This is not a problem in later model routers such as the VIGA 2865, where this function can coexist with hardware acceleration. Another one affecting all current router models is that if bandwidth limit is being used, hardware acceleration will not work. For example, if the normal WAN throughput is 300 megabits per second, but with hardware acceleration the throughput goes up to 900 megabits per second, then when bandwidth limit is enabled to restrict bandwidth for some users, the WAN throughput will drop to the speed without hardware acceleration. Another limitation is that DOS defense cannot work for the sessions that have been accelerated. DOS defense is a software-based filter function, so packets need to be checked by the CPU to ensure their validity. When the session has been accelerated, the data packets will not be checked by the CPU. Any inbound-outbound traffic that has not been added to PPA will be filtered using DOS defense. Some other limitations worth mentioning. While QoS performance for outbound traffic will increase with hardware acceleration enabled, the Others class in the QoS settings can use more than the reserved bandwidth when classes 1 to 3 are not fully utilized. This can possibly cause packet loss to traffic in one of the classes 1 to 3 if there is insufficient bandwidth available. Another item is that inbound QoS does not work for accelerated sessions. Also, App QoS does not work for inbound traffic, and firewall-related functions cannot work for sessions that have been accelerated. Okay, let's now check out the steps to configure hardware acceleration. There's an application note number 5308 in our knowledge base that goes into more detail. I'll include a link to that in the description below. The configuration options are different between older router models and the latest models. In older routers, there are two options for hardware acceleration, auto and manual. In auto mode, hardware acceleration will automatically apply to the heaviest TCP sessions. In manual mode, the network administrator can choose to accelerate the sessions of a certain protocol, source IP, or QoS class. The latest router models, such as the VIGA 2865 and VIGA 2927 series, support more features in hardware acceleration. Features such as data flow monitor, traffic graph, quality of service, and bandwidth limit can coexist with hardware acceleration when it is enabled. It allows you to choose NAT to accelerate sessions from LAN to WAN, and also IPsec to accelerate sessions from VPN to WAN with IPsec VPN protocols. In the configuration menu, you can select which type of traffic to accelerate, as well as the protocol used, TCP and UDP. The exception list option allows you to disable hardware acceleration for certain hosts. To configure the exception list, first choose the host from ARP table, then select the exception type. You can enter a description here if you like. Now click Add to add the profile in the list, and finally click OK to apply. In the latest router models, such as the VIGA 2865 and 2866 series, hardware QoS has been added in firmware version 4.4.0. If you want to use the hardware QoS function, you'll need to ensure that hardware acceleration has been enabled as shown previously. Also note that software-based QoS has lower priority than hardware-accelerated QoS. To check if hardware acceleration is working, you can telnet to the router and run the command PPA-V in the router's CLI. The results displayed for PPA LAN and WAN are the accelerated traffic. You can also type PPA-D3 to see if hardware acceleration is working on a session from the LAN, and PPA-D4 to see if it is working on a session from the WAN. If you find that you're not seeing the expected improvement in WAN performance when hardware acceleration is enabled, there are some things you can do to troubleshoot. The first thing to check is that devices attached to the router are capable of the higher speed. You can try using another PC to test, and maybe another router to verify it is not a problem with the router. The next thing to check is that you have the correct physical link speed for the internet connection. This can occur when the router Ethernet WAN port is connected to an external modem or NTU, and the WAN port does not correctly negotiate the correct line speed and duplex settings. For example, the ISP provides a 300 megabits per second line, but the router's WAN port only links at 100 megabits per second, so the router will not achieve 300 megabits per second throughput. You can try the port ? or port WAN FC CLI command to adjust the physical link settings. Another option you can try is to add a switch between the router's WAN and the ISP's modem, and then see if the router can get the expected performance after that. For DSL WAN, you can check its physical link speed in the online status page, or with the CLI command VDSL space status. If the router links at a lower speed than another router does, try other DSL modem codes, which you'll find on our downloads page for each model, or adjust the SNR margin and see if that increases the sync speed. Quality of service and bandwidth limit functions will restrict the router's performance and can affect the router throughput. So try disabling quality of service and bandwidth limit functions and check if the speed improves. Similarly, the UDP flood option may block UDP packets if the packet rate goes over the UDP flood threshold. You can try disabling the UDP flood option in the firewall DOS defense function and check if there is an improvement. You can also use iPerf to test the WAN performance through the router in a lab environment if you want to run a test independent of an internet connection. You can use the suggested session number as well as a single session to gauge performance. Another item we can look at is the MTU size. You might pick this up if the performance degradation is noticeable when visiting particular internet sites. To overcome this, try reducing the MTU value in the router, which can be changed in WAN Internet Access Details menu page. If you haven't done so already, enabling hardware acceleration in the router will usually increase WAN performance. To check if data traffic is being accelerated, you can telnet to the router and run the command PPA-V. This will show which traffic type has been accelerated. If you don't see an entry for this command, that indicates that no traffic is being accelerated. There are some other factors that can affect hardware acceleration. VIGA router's hardware acceleration can accelerate TCP/UDP traffic only. Traffic that doesn't have a TCP or UDP header, such as fragmented data packets, will not be accelerated. If sessions do not appear in the NAT session table, they also cannot be accelerated. Sessions blocked by firewall settings will also not be accelerated. As mentioned earlier, when hardware acceleration is enabled, the accelerator traffic will bypass some functions, such as DOS defense and bandwidth limit. Okay, so to summarize, today we started by looking at what hardware acceleration is and how it works. We also looked at some limitations when hardware acceleration is enabled. This was followed by steps to configure hardware acceleration in Draytech routers. Finally, we looked at some tips to troubleshoot low WAN performance when hardware acceleration is enabled. Okay, that's it for me for this webinar, but please stay tuned. We'll be online standing by to answer any questions in the live chat on the right of your screen for the next 5 minutes. For more information about Draitec products, please check out our website at www.draitec.com.au or send us an email to sales@draitec.com.au or give us a call on 02 9838 8899. Don't forget to like and subscribe below, and if you'd like a notification anytime we put up a new video, please give the bell a click too. Thanks and bye for now.